There. So now that we've went over the conceptual underpinnings of classes, inheritance, why you'd want to use them, what's the point, I want to actually jump into some code examples so we can start to get into the nitty-gritty of how this works. One note, if you haven't watched this series on instantiation patterns, it's necessary you do that before watching these videos. I'm going to reference a lot of things like prototype chains, the keyword new, that will be very unclear to you unless you have a strong understanding of how classes already work in JavaScript. So I'll put the link in the description. Please watch through that first. So what are we going to code today? Well, I want to code a very simple idea. Bees, a class structure of bees. So on the top, the most basic level is just a normal bee. It can fly, it can buzz, right? And subclassed to that bee, we have a builder bee. Maybe this guy can carry stuff, he can build stuff. And we have a warrior bee. Maybe this warrior bee can, I don't know, fly faster than a regular bee. Maybe it can throw spears, right? So we're going to build this out into code. So let's jump in. So a basic class in ES6, as we know, looks like this. And we instantiate it with the keyword new, var my bee equals new bee. Okay, now let's give this bee some properties. This dot name, and this will be user defined, equals name plus the bee. That way, whenever we give it a name, if it's John the bee. This dot color, we'll also give it a user defined color. And then what else can we give it? How about a position? That way we can represent movement. So just to clear up anything, I'm going to represent movement in code by having a position number. And as that position number increases, it represents movement. So if a bee is at position 0, it hasn't moved. If it's at position 10, it's moved. Position 100, it's moved very far. Cool? All right. Well, this looks great so far. Let's just console log this bee and see what we got. Undefined the bee. Aha! I did not give it a name. So we have to invoke this with both a name, we'll do John, and a color, we'll do yellow. Okay, let's clear this and run it again. There we go. Name, John the bee, color yellow, position 0. Great. Now, just to recap very quickly, what the keyword new does, implicitly in your code, it adds these two lines. Right? It sets this to a new object, set to the prototype of the bee class, and then it returns this. If you're not clear on how those work, don't have time to explain them in this lecture, please go back to the instantiation patterns lecture. Great. So we have a very simple class. You should be totally familiar with everything that's going on here. Okay? So now let's make our warrior bee class. Warrior bee, again, it's going to do the same thing. It's going to take a name and a color. Now, also it's going to be instantiated in this exact same way. Var my warrior bee equals new warrior bee. We'll call it, what's a good warrior name? Alexander. And its color will be red. Okay, now let's console log this warrior bee. Okay, how do I make that go away? There we go. Let's console log the warrior bee. Nothing on the warrior bee, right? We haven't added any properties yet. So right now, the warrior bee class is returning an empty object. So here is the fundamental question I want to pose to you. With subclassing, what we want to do is we want to have everything here, all these properties, on our warrior bee object, on an instance of warrior bee. Well, how do we do that? Okay, A naive approach is to literally just copy and paste it. Of course, that would totally work, but in code, you don't want to repeat yourself, right? The idea is we write all the functionality once, all the properties once, and then we don't have to write it ever again. So how can we make this happen? I want you to think for a second and think if you can come up with a way to have all of this code applied to our warrior bee. What could we do? I want to give one note that I think will help your thinking, okay? Again, we're invoking warrior bee with the keyword new. So implicitly inside warrior bee, there are two lines. This equals object.create, warrior bee.prototype. That's one, and then below that, implicitly is return this. So we're referring to our instance of warrior bee with the keyword this, okay? But how do we get all of the bee properties to apply to warrior bee? Luckily, I have slides for that. So let's look at this together. Give me 1 second. Okay. Sorry about the delay there. Okay. So luckily I've rewritten the entire code we just wrote into slides so we can go through these very efficiently. So again, we have our function, that's a bee. It creates, it assigns a name and a color and a position to the keyword this. And then we have our warrior bee function. And the question is, how do we get all of the assignments from bee onto warrior bee? Well, just as a reminder, let me skip through here. When we instantiate a new warrior bee, these two lines are implicitly added into the code. This equals object.create, and we return this. So here's an idea. We have two thises in our code, right? We have the keyword this within warrior bee, and we have the keyword this within bee. Now, right now, the keyword this in bee refers to the global object because we're not invoking the bee function with the keyword new. So when we say this without any sort of context, it automatically refers to the global object, okay? But the keyword this in warrior bee is an actual instance of warrior bee, right? It's an object that represents an instance of warrior bee and will eventually be, exported by the function, right? The classes give objects. The keyword this, in the case of warrior bee, just refers to that object that is a warrior bee. So what do we want to do here? What do we want to do with these keyword thises? I'm going to use the word context from now on, just to refer to the different, in the warrior bee, the context refers to warrior bee instance. In the bee function, the context refers to the global object. So what do we want to do? How can we use this to make warrior bee inherit from bee? Well, let's imagine this. I'm going to walk through the interpreter and see if this makes sense to you. Remember, a function is not, the code inside a function does not run until the function is invoked. So the interpreter goes up, starts here, it says, oh, function b exists, cool. It doesn't yet run the code, it just remembers that that function exists. Then it goes to warrior bee. It does not yet run that code, it just remembers that the function exists. And then it says, okay, we're making a new variable called myB, and we're assigning it to what? New warrior bee. So now the interpreter jumps into warrior bee and is now running the code inside warrior bee. Okay, the first thing the interpreter does is it makes a this. It assigns the keyword this to a new object. Okay? Now, something could happen in the middle, maybe, and then it returns the keyword this. Okay? So what can we have happen between the blue warrior bee instance being created and referred to with the keyword this and returning it, right? Well, what about this? What if we took the blue context? What if we took the warrior B instance, we create it, and then what if we pass it to B and say, hey, all these properties, assign them to my blue instance, then give it back to me, and then I'll return it. So what if between this line and this line, we take our blue this and we pass it to the B function, so the B function assigns a name to it, assigns a color, assigns a position, and then we return this. That is exactly what we do. How do we do it? How can we explicitly set the context of a function with the call method? Call, given a function, you call the function and you're able to, the first argument is what you want the context to be set to. So notice carefully here. Before call, the color of these were green because they referred to the global object. But once I added call and I called the B class, they became blue. Why? Because that's what I'm passing in, is this blue object. So let's go through the interpreter one more time. Interpreter starts at the top. It sees the B function. It doesn't run the code. It just remembers that it exists. Keeps going. It sees warrior B. Doesn't run the code. It just remembers that it exists. Okay. Then it says, oh, we're making a new variable called myB. What are we assigning it to? Oh, we're invoking warrior B. Well, let's jump into warrior B. So the interpreter is now inside the warrior B function. It's running the code. What is the first thing it does? Well, it creates a new object that represents our warrior B instance, and it assigns it to the keyword this. So now whenever we say the keyword this, we're referring to our warrior B instance. Okay, then b.call. The interpreter goes, oh, we're invoking B, but in B, whenever I say the keyword this in B, I'm referring to the first argument. Okay, I'm referring to the blue this. So it jumps into B, and remember, we explicitly said what the keyword this refers to in B, so it's been replaced with our warrior B instance. So now when we say this.name, we're no longer referring to the global object, we're actually referring to our warrior B instance. So we add a .name property to our warrior B instance, and then we add a .color property to our warrior B instance, and then we add a .position property to our warrior B instance, and then this code finishes, and then this whole line finishes, and we jump back down here, and we return our warrior B instance, which has had these properties added to it, the name, the color, and the position, all from the B function. Okay? I want to note one thing here that may be a little confusing. What are these second arguments in call? What does this mean? Well, it turns out that call allows you to not only call a function with a specific explicit context, but also with any arguments you want. So because we're invoking warrior B with John and yellow, we want the name to be John the B, and we want the color to be yellow. So how do we pass on these arguments all the way to B? Well, let's walk through the interpreter. Warrior B gets invoked. So now we're inside here. And the arguments for name and color on the invoked warrior B were John and yellow. So this name is John, this color is yellow. And then we call B. And what are these name and color? It's John and yellow. So now when we go all the way to B, this name and this color are now John and yellow because we passed the arguments all the way through. So the name is John B, color is yellow. Let me run this code, and then we can look at this one more time, okay? So, warrior B, what are we gonna do? We can say B, let me actually just one more time run this code just to confirm that it doesn't do what we want right now. Right, blank object, okay? B.call this name color. Boom. Now our warrior B has a name, Alexander the B, a color, red, and a position 0. But none of that code is in warrior B, right? What is happening? We create again, implicitly in the lines of code, you don't see it, but implicitly, we create a new object to represent the B. We pass it to the B function. It decorates it with name, color, position, and then we return it. This is still a little confusing. I have one more tool that I think can help you understand exactly what's going on here. Which one is it? It is It is here. Okay, so this is the one right here. Give me 1 sec. Okay, so if you're having trouble conceptualizing what exactly is happening here, this may be helpful. So we'll go back to our ice cream example, right? Imagine we have a factory that creates vanilla ice cream cones, right? And just like a normal subclass, we want, inside this factory, we have a pipe that gives a cone, and then a pipe that gives a vanilla, and then a cone goes down the assembly line, and then it takes the vanilla and makes a vanilla cone, and it gives you this vanilla ice cream cone. Very simple factory. Okay. Again, it gives you a cone, it puts vanilla ice cream on the cone, and then it returns the whole thing. Okay, but let's imagine we have another factory, and we want it to make vanilla ice cream with sprinkles. Okay, so again, we don't want to reinvent the wheel, we want to inherit from the parent class. So here's this new factory. Imagine the new factory still creates the cone because we still need a base. But then it takes the cone, passes it to the parent factory to put on the vanilla ice cream, then comes back down, puts on sprinkles, and eventually returns the cone. So in other words, the subclass, the child class, starts the work, it builds the base, and then it gives it to the parent class to decorate it, to give it the stuff, to give it the functionality, to give it the ice cream. Then it comes back down, and maybe it decorates it one more time, and then it returns it. And that's exactly what is happening here in our code. Our warrior bee class creates the initial object. It creates the base, it creates the cone. And then it passes that cone to B, the B function to be decorated with name, color, and position. And then it comes back to warrior bee and it returns it. Right? In fact, we can even, on warrior bee, we can apply more stuff. Like we could say, warrior.battlecry equals, I'm tough, right? So again, what's happening? Warrior bee is creating an object, it's passing it to B, B is decorating with name, color, and position, it's coming back down to warrior bee decorates it with the battle cry, and then it gets returned. So let's just look at this code here. All right, now we have a bee with Alexander, a name, a color, a position. So these are all decorated on in the bee class. And then we have a battle cry, which we add on in warrior bee. Okay? So that is how property inheritance works in classes in JavaScript. Okay? Use .call so that you can pass your instance to a different function to inherit all those properties, then it comes back down, you can add more properties to it, and then it gets returned. Okay, next we're going to talk about how you can inherit methods. So stay tuned.